Good evening, everyone. Welcome back to our another lecture on design of concrete structures, and this is the sixth prestressed concrete flipped glasses video. And today we are going to discuss about another type of problem, which is the tendons with a parabolic shape, and finally the load balancing method. Okay, so let us come to the theoretical part of the tendon with the parabolic profile. Let us say this is a prestressed concrete beam, okay, and it is subjected to a live load of W per meter. Yeah, and the tendon, as you can see, this is the profile of the tendon, which is a parabolic shape with a sag at the center, maximum of H, and pre-stressing force P. Right, and as you know that we will pull both sides of the tendon. So what is happening is there is a force which acts up, actually, as you can see, around the length of the cable. When you push it from both sides, this there is a force which will be acting opposite and going up, actually. All right, so you can see here. So what is happening is this W per meter is acting down, and this force through the cable, it is acting upward, actually. Right? Let us say that load is WC. So the net effect, okay, net weight which will cause bending moment is W minus WC. So our aim is to find out. Let us see how to find out WC. See, you would have studied the cable and suspension bridges. In cable and suspension bridges, the tension in the cable, if the length of the cable is horizontal length is L and the dip is H and the load on the cable is W, then the tension on the cable is WL square by 8H. So if you know the, for us the tension here, it is P, the pre-stressing force. So if you know the force P, or the tension other way, then we can find out W, the load on the cable. W is nothing but 8pH by L square. So because of this the pre-stressing force, the force on the cable which is acting opposite direction is 8pH by L square. So the actual the net load, because this is acting downward and this 8pH by L square is acting upward, so the net load which will cause bending moment is W minus WC. So this is the load we should use it for finding out bending moment, WL square by 8. Are you getting me or what? This WD we can find out because it is self-weight. Assume that this is a live load. W is live load, and MD we can find out using, first you will find out the WD and WD L square by 8. Now one thing you should note here, it is the tendon is passing through the CG, neutral axis, actually. So there is no eccentricity. So PE by Z term will not come. So your tension, stress on the top will be P by A. How P by A? P by A means since it is acting inclined, there will be a force, the horizontal component will act like this. So actually it will be P cos theta. If this is theta, this will be P cos theta. But since theta is very small, what we do is we will take P is equal to P cos theta. So this will be P. So P by A. This P will create compressive stress. So it will be P by A, and because of the dead load, what happens, it will bend down. So top is compression P by A plus MD by Z, and live load because of W it will cause compression only. So what only thing is that when you find out ML, WL square by 8, you should use W minus WC. Okay, same way you can find out lower compressive stress, lower stress also, lower stress in the fiber also. Yeah, so these things you please should keep in mind, actually. Let us do a problem so it will be more clear. Below figure shows a prestressed concrete beam provided with a tendon having a parabolic profile. The total external load on the beam is 35 kN meter. Total external load, meaning is that it is a live load on the whole span, which is 6 meters. Span is given as 6 meters. Calculate the extreme stress of the mid span as well as support. You have to find out the stress at top fiber and bottom fiber at mid span as well as support. the tendon carry a pre-stressing force of 1000 kilonewton. So P is given to you 1000 kilonewton. Cross section of the beam is given 400 and 600. The load acting on the beam is given 35 kilonewton per meter. The sag of the beam, sag of the tendon is a parabolic profile, and at the center the sag is h, small h. The dip is 10 centimeter, and the length of the beam, the span of the beam is 6 meter. Yeah. So it is asked to find out the stresses at midspan as well as the support. So let us see what are the things will come at midspan, what are the things will come at support. Let us see the case at midspan. See, midspan, you know that there will be a bending moment will be there due to the dead load. Okay, same that will be present. The bending moment due to live load will also be there, that will be present. And if there is an eccentricity, then moment will also be there. P into E moment will be there. But in this case, we don't have an eccentricity. Why? Because the tendon is passing through the, here at the end, it is passing through the, it is in coincidence with the, or coinciding with the neutral axis. So here it is E will not be there. Therefore, PE will, moment will not also be there. But normally, if E is present, then PE moment will also be there. Then other thing is P by A because of this force. Okay, P by A will be there. When you come to support, see, you know that when there is a beam is subjected to UD load, the bending moment at the support is 0. MD, bending moment due to dead load will be 0, because the bending moment diagram will be like this, parabola like this. Here it is maximum at the center, and as we come to the support, it is 0. And bending moment due to live load is also 0. And if there is an eccentricity, again I am telling, if there is an eccentricity, then you will be having a moment due to P into E. But in our case, there is no moment here. I mean, there is no eccentricity here, so PE will be 0. But not in general case, if a eccentricity is there, you will be having a moment, and you will have a P by A also, right? That is a axial stresses. So let us find out the things. P is given to you, it is 1000 kilonewton. Yeah. Area is 400 and 600. So P by A you will get 4.17 megapascal Newton per millimeter square. And as you know, when you pull it up, the previous case I said, when you pull the tendons will try to come up. The tendons will try to come straight. So this tendon will exert a pressure in the opposite direction. It will apply a load on the opposite direction. That load is 8 pH by L square. So the effective load will be, net load will be W minus WC. WC is 8 pH by L square. So let us find out WC, 8 pH by L square, which will come around 22 kilonewton meter per meter. So net load will be W minus WC. W is 35, which is acting downward. WC is acting upward. So 35 minus 22 will be 13 kilonewton per meter. So this is the load which will create bending moment. Yeah. So ML means bending moment due to live load. It is equal to WL square by 8. W is 13. Should not take 35. 35 is acting downward, and WZ is acting upward. So effective will be 35 minus 22 is 13 kilonewton per meter. So ML you will get 58.5. And MD is WD into L square by 8. What is WD? The self weight. Self weight is 0.4 into 0.6 into 25. So you will get it is 27 kilonewton meter. And Z we need to find out. Z is BD square by 6. Okay, so ultimately at a midspan you will have P by A plus MD by, because MD by Z, ML by Z, as you know, these loads are always acting downward. Downward will create the beam to bend downward actually. So top will be compression, bottom will be tension. So P by A plus MD by Z plus ML by Z. So you will get plus 7.73. And sigma L at lower fiber, it is P by A minus MD by Z minus ML by Z. So you will get plus 0.6 Newton per millimeter square. Okay. So at support as I told you, you will have only this P by A. MD will not be there because moment will be 0 at support. ML will not be there. When you want to live load will be 0 at support. And there is no P and E also, because our eccentricity is 0. So you will get 4.17 and 4.17. So this is the stress diagram. Okay, so hope this is clear for you. Now we will see another important part of the pre-stressing concrete is load balancing concept. What is a load balancing concept? So this is the one usually whenever we do these practical problems, practical design of pre-stressed concrete, this load balancing method or load balancing concept is widely used actually. It is being used very widely. So what is the advantage of this one? Let us see. You would have seen this one if you remember, the beam with the bent up tendons. This one is beam with parabolic tendons. So let us say in this case load is W, a point load is acting downward. So what is happening is when you pull this tendon, so you know that there is a 2p sin theta force will be acting upward actually. And for calculation purpose, what you will do, you will take the net moment, net load W minus 2p sin theta. And here, load W per meter is UD load is acting downward. And when you pull the tendon, the parabolic tendon, the load, the parabolic tendon will exert upward is 8 pH by L square. Okay, and what you will do is you will take the net load. Net load is W minus 8 pH by L square for finding out the bending moment. Yeah, is it? Now this concept we can use it for effective design of what is that, the pre-stressed concrete. For example, the net load only we will be using for finding out the bending moment, W minus 2p sin theta. If W minus 2p sin theta is 0, then what will happen? Will not be having any bending moment. Agree? So if there is no bending moment, so we are happy as civil engineers. There will not be any stress, major stresses. When there is a bending moment is there, bending stress will be there, deflection will be there. So how to make it this one 0, W this net force W minus 2p sin theta, how to make it 0? You can make it 0 such a way that if 2p sin theta is equal to W, then W minus 2p sin theta is 0. Same way, if 8 pH by L square is equal to W, then W minus 8 pH by L square is equal to 0. So how to make it 2p sin theta to W? We can do two things. One is, we can adjust theta. How to adjust theta? Adjust theta means eccentricity. If you reduce eccentricity, theta will be less. If you increase eccentricity, theta will be more. So either you can play with the theta and p to make the 2p sin theta is equal to W. Okay. So suppose you have a load, already the load. So only variable is sin theta. So how to change theta? By changing the eccentricity. Same is the case here also. You can increase or decrease the dip h. Okay, so that finally you can make this WC is equal to W. So W minus WC you will get 0. When you get 0, that W minus WC, the load is 0, going to be the 0. The net load is going to be 0. So your moment is also going to be 0. Right? Understood? So that is what we are going to do. So in this load balancing concept, what we do is they will give you the load, they will give you the tendon's force also. So you should find out the eccentricity. You should keep the tendon profile. You should give how much will be the eccentricity, such a way that W minus 2p sin theta is 0. Otherwise, if it is in the case of a in the parabolic profile, then you should give the dip h, small h. Load will be given to you, P will be given to you, this load, live load will be given to you, beam section will be given to you. Your job is to find out the profile of the tendon. Profile of the tendon means this eccentricity, the dip you should find out. Are you getting me or what? So what is a load balancing concept? It is as simple as that. If a beam can be designed such that this upward force exerted by the cable exactly neutralize the downward force, then it is called load balancing. So this force is equal to this force, then it is load balancing. That is how. So our aim is to find out the profile of the tendon such a way that upward force equal to downward force. So let us do a problem. Okay, so it will be clear to you. Determine the profile of a load balancing cable for a beam of span 6 meter carrying on inclusive load. On inclusive load meaning live load plus dead load. Okay, on inclusive load of 40 kN per meter. Full stop. The pre-stretching force on the tendon is 1200 kN. So P is given to you, 1200 kN. The beam section is 400 by 600 mm. Okay, so you need to find out the tendon profile. Okay, so one thing you should keep in mind, how do you know that whether I should go for a parabolic profile or a bend up profile? So the answer is very simple actually. So you can use parabolic profile for load is UD load. If the point load is given to you, then you can use a bend up profile. Okay, so I don't know how many of you have noticed. See, if it is a point load, the bending moment diagram, the shape of the tendon will be like that of bending moment diagram. If there is a UD load, then shape of the diagram, bending moment diagram will be like same as that of a what you call it's a tendon profile. Okay, so the answer is very simple to you. If you want to go for parabolic, if you check whether this is a UD load, or the case of UD load, if it is UD load, go for parabolic profile. If it's a point load, go for bent up profile. So our case it is a UD load, so I will go for parabolic. So our aim is to find out H, profile of the tendon, using balancing method. So I should get 40 is equal to 8 pH by L square. Okay, so let us write down the given data. WD plus WL, it is equal to 40 kilonewton. Okay, because it is given as all inclusive load. Pre-stressing force P is 1200, B is 400, and D is equal to 600. So our aim is to find out H. Okay, because P everything is given. L also you know, it is known to you. Okay, so we should find out H. So we know that 40 kilonewton per meter is equal to 8 pH by L square. That is the case. Then only we call this a load balancing. Downward load is balanced by upward force, upward load. Okay, so if that is the case, then W minus Ws will be 0. So you will be bending moment will be 0. So this is the case. Okay, if the downward force is equal to upward force, then the net force which causing bending moment will be 0, and as a result bending moment will be 0. So we should find out W is equal to WC, that is 40 is equal to WC, you know, 8 pH by L square. Therefore H is equal to 40 L square by 8 P. You will get 150 mm, 0.15 centimeters, 150 mm. So, and meaning is that you should keep the tendon, parabolic tendon, in such a way that center you should give 150 mm. So what happens? There will not be any bending moment. Okay, so that is the end of the story. Hope this is clear to you. Thank you.